All right, test review day. Here we go. I'm just going to breeze on through these. Okay, so first things first, write the linear equation of the tangent line to this curve at the given x value. So if the curve is y equals 2x squared minus 6x plus 3, and I want to find the tangent line at x equals 2, in other words, I want to touch the curve at that particular point in the direction of where it's going at the time. I want a visual representation of the velocity. So for instance, well, I want to figure out where the point is. Let me get my multicolored pen. There we go. So basically what I'm trying to do is figure out what the point is. So I want to figure out what f of, what's my point? X equals 2. So f of 2. So that's 2 times x squared minus 6 times x plus 3, where x is equal to 2, because that's where I want to figure out where my tangent line is. Okay, well, that, let me just breeze on by with this. Well, that's 2 times 2 squared, so that's 2 times 4. Negative 6 times 2 is negative 12 plus 3. So that's 8 minus 12 plus 3. 8 minus 12 is negative 4. Negative 4 plus 3 is negative 1. Therefore, my point is at 2, comma, negative 1. So that is going to be my x1, y1 when I get into point slope form. Well, if only there was a way to figure out what the slope was. Luckily, this is calculus, and we have this magical thing called the derivative. So first things first, we know that f of x is equal to 2x squared minus 6x plus 3. So that means f prime of x, the derivative with respect to x of this curve, means that we take the power rule. 2 times 2, that'd be 4. Take away a power, that'd be 4x to the first power. The derivative of negative 6x is negative 6. And the derivative of positive 3, the derivative of any constant for that matter, is 0. So I don't really care too much about that. And now I can figure out what the slope is at x equals 2. So that is 4 times 2 minus 6. Well, that's just going to be very, very exciting now, isn't it? 4 times 2 is 8. 8 minus 6 is 2. So the point is 2 comma negative 1, and the slope itself is 2. Okay, so that's my m. Okay, so now, once I've got my point, once I've got my slope, I go into point slope form. Y minus y1 equals mx minus, oh, I messed up. Well, let's try that. Take 2. Y minus y1 equals mx minus x1. So my y1 is negative 1, my m is 2, and my x1 is 2. So now I'm going to plug it in the formula. Y minus negative 1 is equal to 2x minus 2. Okay, are there any double negatives? There's my double negative. I ain't got no time for no double negatives. Y plus 1 is equal to 2 times x minus 2. So now I distribute the slope. Y plus 1 is equal to 2x minus 4. And now I'm going to distribute, I'm going to isolate the y by subtracting 1 from both sides. So that leaves me with my tangent line, which is y equals 2x minus 5. Now, I really put my heart and soul into this because I've seen calculus teachers teach it with just this and no visual, or just visual and no algebra. I think you need both. I struggled with this in college. I struggled with this when I was seeing this for the first time in high school. You need to see both. You need to be awesome at both. So let me just get this formula up there. Y equals 2x minus 5. And the graph was y equals 2x squared minus 6x plus 3. So let me show the graph. So as you can see, y equals 2x squared minus 6x plus 3 is a parabola. I just made it dotted. And I care about the slope when x is equal to 2. So when x is equal to 2, there we go. When x is equal to 2, y is equal to negative 1. So I want to figure out if our tangent line touches this part of the curve in the direction of where it's going. It looks like it has a slope of 2. So let me plug in the tangent line. Once again, keep an eye on this point right here. Oh, never gets old. Never ceases to amaze me. If I zoom in close enough, you'll notice that it touches the curve just at that one point in the direction of where it's going. And I just fell in love with calculus all over again. All right, problem number 1 is done. Let's do problem number 2. Another parabola. Y equals negative 5x squared plus 4x minus 3. Find the slope of the tangent. Sorry, find the equation of the tangent line at x equals 1. Hint, hint, teachers are lazy. Calculus teachers love easy problems. I didn't say anything. I didn't say anything revealing about how calculus teachers are lazy and like x equals 1. I never said that. All right, so first things first, let's do the point. So in order to find the point, I need to plug in x equals 1 into that equation. So let's do f of 1. So f of 1 is negative 5 blank squared plus 4 blank minus 3. So now that I plug in x equals 1, oh yeah, look how complicated that is. So negative 5 times 1 squared, well, let's just spoil it. Negative 5 times 1 squared is 1, so negative 5 times 1 would be negative 5. And then 4 times 1 would be positive 4, and then minus 3. Negative 5 plus 4, that'd be negative 1, and then negative 1 minus 3 would be negative 4. So what this means is we have a point 1 comma negative 4, and that's where the point of our tangent line is going to go. So that's going to be my x1, y1. How do we figure out the slope if it's a curve? That makes no sense. Oh, right, derivative. The instantaneous slope can be achieved by taking the derivative of f of x. So remember that f of x is negative 5x squared plus 4x minus 3. And I want to figure out f prime of x. So f prime of x is negative 5x squared's derivative. That's going to be negative 10x. And the derivative of positive 4x is positive 4. And the derivative of negative 3 is gone because it's a constant. The slope of a horizontal line is always 0. So now I'm going to do f prime of 1, the exciting 1. So that's negative 10 times 1 plus 4. And now I've got negative 10 times 1, which is negative 10, plus 4. And negative 10 plus 4 is negative 6. So therefore, the slope at x equals 1 is negative 6. That's a pretty steep slope. So now I just use my algebra. I've got a point, I've got a slope. I go into point-slope form because it never leaves. All right, y minus y1 equals mx minus x1. Okay. All right, so y minus y1 equals mx minus x1. Well, now I'm going to plug in the pieces. y1 is negative 4. M is negative 6. And x1 is positive 1. Okay. Are there any double negatives I can clean up? Yeah, I don't like y minus negative 4. Why don't I make that y plus 4? is equal to negative 6x minus 1. So now that I've cleaned up the double negatives, I'm going to rewrite the problem, but distribute that negative 6. So that becomes negative 6x. Negative 6 times negative 1 is positive 6. Okay. Now I want to get y isolated. So I'm going to get y isolated by subtracting 4 from both sides of the linear equation. So now I get my tangent line, which is y equals negative 6x, positive 6 minus 4 is positive 2. So there we go. There's our tangent line. Let's see if it holds up true with our curve. So our curve is negative 5x squared plus 4x minus 3, and my tangent line is negative, y equals negative 6x plus 2. Let me just get that set up. So I'm not gonna, all right, so the dotted blue graph is the curve that we're talking about. And I wanna figure out when x is equal to 1, that means that y is equal to negative 4. There we go. So let me just zoom in a little bit. There we go. I want to see if the tangent line that we figured out, y equals negative 6x plus 2, touches this curve at 1 comma negative 4, and it has a slope of negative 6. It looks like a negative slope. Bam! Oh, I could watch this all day. But then I miss my sports, but sports are canceled right now. Yeah. That's awesome. Okay, let me just X that out. Okay, and our next curve is, so now we're out of the world of quadratics, the cubic function. X cubed minus x at x equals negative 2. Just to give a little bit of variety, nothing too scary. Okay, first things first, I need a point. Math lessons are meaningless without a point. What's the point? So f of, we want to figure out the slope at x equals negative 2. Okay, blank cubed minus blank, where the blank is negative 2, because we're plugging it in. Okay, piece by piece. Negative 2 quantity cubed. So we have a negative base. Okay, that kind of scares me. If the exponent is odd, then the output will be negative. If the exponent is even, then the output will be positive. So negative 2 quantity cubed is going to be negative 8 minus negative 2. I don't like double negatives, so let's convert that to a positive. Negative 8 plus 2 is negative 6. Okay, so now I've got a point, negative 2, negative 6. So that's going to be my x1, y1. Okay, now I got to figure out what my slope is, aka find the derivative, find the instantaneous slope at x equals negative 2. So now we know that f of x is equal to x cubed minus x. So let's figure out what f prime of x is. Let's ddx both sides of the equation. Okay. The derivative of x cubed with respect to x is 3x squared. And the derivative of negative x, well, there's an imaginary 1 right there. So that'd be negative 1. Because we subtract the first power and it'd be 0. The 0 power, so it's just the constant negative 1. Now I want to figure out what the slope is at x equals negative 2. All right, piece by piece, I'm going to do the exponent first. Negative 2 quantity squared, so that's an even exponent, so it's going to be a positive output. So that'd be 3 times negative 2 quantity squared, that's positive 4, minus 1. 3 times 4 is 12, minus 1 is 11. Okay. So the slope at x equals -2 is positive 11. Okay, so that's going to be a very steep slope. But now we know that since the slope is our letter m and we've got an x1, y1, let's go to the formula and let's figure out what the equation of the tangent line actually is. Okay, so we've got y minus y1 equals m, x minus x1. All right, so remember that our y1 is -6. Our m is 11. And our x1 is -2. Okay. Are there any double negatives I need to clean up? Yeah, in fact, y minus y1 is a double negative. X minus x1 is a double negative. I ain't got time for no double negatives. So that's y plus 6 equals 11, x plus 2. Okay. Now, distribute the 11. I get y plus 6 is equal to 11x. 11 times positive 2 is a positive 22. And now subtract 6 from both sides. And the tangent line is equal to y equals 11x. 22 minus 6, that'd be 16. So that's going to be my tangent line, y equals 11x plus 16. So let's figure out what the graph looks like. So I'm going to look at x cubed minus x. Oh yeah, so that's my bended curve. We're going to talk more about that in the next unit. So what does it mean when it bends? Okay, so I'm going to look at x equals -2. Okay, so when x is equal to -2, yes, it matches up with y equals -6. Okay, and I want to see if this has a slope of 11, if this tangent line has a slope of 11 and it touches the curve at -2, comma, -6. Boom! Love it. Love it. See that red touching the curve? It never gets old. Okay, X that out. Put this away for now. Okay, next problem, number 4. We've got 3 more to go. Ah, man, oh man. F of x is equal to the square root of 25 minus x squared, and I want to figure out the equation of the tangent line at x equals 4. So let's figure this out. Well, let me start with the easy part. We need to figure out what the point is. Okay, so what we need to do is plug in the f of x formula. Leave it as a blank wherever there's an input. Square root of 25 minus blank squared. And what goes in the blank? We want to figure out where x equals 4 lies on the curve. Okay, so we've got 25 minus 4 squared. So that's 25 minus 4 squared would be 16. 25 minus 16 is 9, so we've got the square root of 9. And the square root of 9 is 3. So what this means is as the function you plug in x equals 4, your point is x equals 4, y equals 3. And that is going to be my x1, y1 of the curve. Okay. Now, go back. I want to figure out what the slope is at x equals 4. Oh, not slope is equal to 4. Come on, ink. There we go. I want to figure out what the slope is. Good enough. The slope at x equals 4. Well, if I have a function the square root of 25 minus x squared. Well, how do I translate the square root to my liking? I'm going to make the whole thing to the 1/2 power. So that's 25 minus x squared to the 1/2 power. Okay, I've got a function inside of a function. So for now, remember, this is chain rule. If I want to figure out the derivative of green to the 1/2 power, well then f prime of x is equal to 1/2 of green to the negative 1/2 times green prime. So we're going to do 25 minus x squared, and then we're going to take the derivative of 25 minus x squared. So 1/2 green to the negative 1/2 times green prime. Okay, so now that we've gotten that part out of the way, I'm going to leave myself a little bit of space. So that becomes 1/2 of 25 minus x squared to the negative 1/2 power. Right? And I'm going to take the derivative of this. The derivative of 25 is 0. Regardless of how big it is, the derivative of a constant is always 0. The derivative of negative x squared is negative 2x. Okay. Let's see if I can clean this up a little bit. Okay, so I've got 1/2. Negative 2x goes on top. 2 goes on the bottom. And if it's a negative exponent, it goes on the bottom. And because it's the 1/2 power, it's the square root. So that's 25 minus x squared in the square root in the denominator. Well, now, can I cancel anything out? I cancel out the 2 with the 2, but now I've got negative x. Okay, now we're in business. We've got negative x over the square root of 25 minus x squared. So now, after all that hard work, let's find the slope at x equals 4. Okay. So now we've got negative 4 over 25 minus 16, negative 4 over the square root of 9. That's negative 4 over 3. So the slope is negative 4/3. Okay, well, it's a fraction. I'm a little bit nervous, but that's okay. Let's go from point slope into slope int. Y minus y1 equals mx minus x1. So now that we've got y minus y1 equals mx minus x1, remember that my y1 is 3. My x1 is 4. Sorry, I went in a different order, but my slope is negative 4/3. Okay. Oh boy. Okay, so now I'm dealing with a fraction. No big deal. No big deal. No big deal. Are there any double negatives in y minus y1 or x minus x1? No. Well, I'm going to distribute the negative. I promise there won't be any I'd rather you understand the process, so I'm not going to put this hard fraction on there. All right, so we've got y minus 3 is equal to negative 4/3 of x. Okay, not too bad for now. Negative times negative is a positive. Remember that I can do 4/3 times 4 over 1. So that'd be 16/3. Okay, now I want to get this y isolated. remember that I'm going to add 3 on both sides, so I'm going to leave this blank for now. Negative 4/3 of x plus 16 over 3. So remember that I want to get this, I want to add 3 on both sides, but I'm going to have to add it as a fraction. So remember that 3 can be rewritten as 9 over 3, because I want common denominators when I add these together. So I'm going to add 9/3 on both sides. It cancels out, and my tangent line is going to be y equals negative 4/3 of x plus 25/3. And again, if fractions make you nervous, I firmly believe in checking your work with the graph itself. So let me plug in negative 4/3 of x plus 25/3. So now I'm going to check, go to home to, all right? So zoom out, and I care about when x is equal to 4. When x is equal to 4, y is equal to 9. I want to see if the slope at this point is negative 4/3, and it will touch that given point. This is why, oh, plus 25 over 3. Okay, did I do something wrong? 25 minus x squared. Oh, to the, I'm sorry, to the 1/2 power. I was like, wait a minute. Okay, so this is the actual graph. Okay, that makes more sense. See, this is why I love the visual, okay? I approach this as a student. So if I plug in x equals 4, yes, the point was y equals 3. I'm looking at the notebook right now. Yeah, so I make mistakes, but it was on the graph. It wasn't on the paper. But just to make sure, this makes more sense, because this looks like a slope that's going down 4, right 3, or just a little bit steeper than a -1 slope. Let's see. Bam! Oh! Ah, yeah, take my moment of glory there. See? Make mistakes and then celebrate the victory. That's how you learn calculus. Multi-sensory learning. Algebra and geometry coming together. This is like the ultimate boss battle in a video game. Whew! All right, 2 more. 2 more. Okay, let me just take this off. All right, number 5. Okay. Write the equation of the tangent line for x plus 2 quantity to the 4th power at x equals -1. Okay. Not so scary, not so scary. All right, well, I need a point. We always need a point. So let me go. F of -1, see? Notice that teachers love their simple points. Their simple points and their simple slopes. So when x is equal to -1, I get -1 plus 2, which is 1. And I take that to the 4th power, which is still 1. 1 times 1 times 1 times 1. So my point is -1, comma 1. So that's my x1, y1. Okay. Now I want to figure out the slope. Remember that I've got f of x is equal to x plus 2, quantity to the 4th power. What rule do I have to use to differentiate f of x? The chain rule. Recall that the chain rule says that if I have a function inside of another function, I'm going to call this green to the 4th power. The derivative with respect to x, the derivative of green to the 4th power is 4 green cubed times green prime. So that becomes 4 times the inner function x plus 2, quantity cubed, times the derivative of the inner function x plus 2. So now I've got 4x plus 2 quantity cubed, and the derivative of x is 1, and the derivative of 2 is 0, so couldn't hurt. I'm just going to plug in a 1 right there. Now I've figured out the slope anywhere. I just need to figure out what the slope is at x equals negative 1. So let's figure out f prime of negative 1. I don't need to write that times 1 right there. So if I plug in x equals negative 1 into this problem, that'd be 4 times, okay, negative 1 plus 2, that'd be 1 cubed. Well, there you go. 1 cubed times 4 is 4. So the slope at x equals negative 1 is 4. And that is my slope. So my x1, y1, and my m point slope to slope int. Here we go. Y minus y1 equals m x minus x1. All right, so remember my point is x1, y1, so my y1 is positive 1. Cool. My slope m is 4, and my x1 is negative 1. So let me plug in everything that I know. I did. And are there any double negatives? Just that x minus x1 part, I can simplify that to become x plus 1. So this whole thing becomes y minus 1 equals 4 times x plus 1. So now I'm going to distribute the 4. So that becomes y minus 1 equals 4x. 4 times 1 is positive 4. And now I want to get y isolated, so I'm going to add 1 to both sides. Here we go. So my tangent line is y equals 4x plus 5. Let's go to the graph. So y equals 4x plus 5. For that, x plus 2 quantity to the 4th power. And I care about what happens when x is equal to negative 1. There we go. Hopefully it has a slope of 4 and it touches negative 1, 1. Boom. Yes. Love it. I love calculus to a certain extent. Okay. Number 6. All right, last one, just to keep your skills sharp. What do we need to do to figure out the equation of the tangent line here? Just think about it. I'm going to do the point first. Start thinking about how you're going to calculate that slope. Okay, so let's figure out the point. The point at x equals 1, very, very exciting, because you can see with a complicated function, your college professors like very simple problems. All right, so let's do f of 1. So that is 3 times 1 minus 1 times 1 squared minus 8 times 1 plus 7. And now I'm going to plug in x equals 1 into all aspects of the function. Okay, here we go. Well, 3 times 1 is 3. And 3 minus 1 is 2. 1 squared is 1. Negative 8 minus 8 plus 7. So that's 2. 1 minus 8 is negative 8. That's right, 1 minus 8 is negative 7. Sorry about that. And then plus 7 is 0. Ooh. So that means that my point is at 1, 0. Not to be afraid, not to be afraid. The y-coordinate is 0. Nothing to be afraid of. Okay. And now I need to figure out what the slope is. So remember that my function is 3x minus 1 times x squared minus 8x plus 7. Let's figure out what the slope is. And in order to figure out what the slope is, I got to do f prime of x and do product rule. Recall that product rule occurs when you have a function u times another function v. I'm going to list out my u and my v. My u is 3x minus 1, and my v is x squared minus 8x plus 7. So let's do u prime. U prime, the derivative of 3x is 3. The derivative of negative 1 is 0. V prime, the derivative of x squared is 2x, and the derivative of negative 8x is negative 8, and the derivative of 7 is 0. So let's do the product rule. Recall that the product rule says if you have a function u times a function v, then the derivative is u prime v plus uv prime. All right, so let's plug in the pieces. U prime, 3, v, x squared minus 8x plus 7, plus u, 3x minus 1, v prime, 2x minus 8. Can you kind of see why college professors like x equals 1 or x equals 0 or something pretty simple? So you don't have to distribute and combine like terms, because the goal is for you to be able to use these rules and plug in the x value. Sorry about this, scrunched up. There we go. So now I'm going to plug in x equals 1, because that's the x value that I care about the slope. All right, just skip right to the chase. Let's do the computations. Well, 3 is 3. 1 minus 8 plus 7 is 0. Plus 3 times 1 is 3, minus 1 is 2. 2 times 1 is 2, minus 8 is negative 6. So this becomes 0 plus 2 times negative 6. Well, that's going to be negative 12. So that being said, my point is 1, 0. My slope is negative 12. How exciting. x1, y1, m. And could you imagine what the slope would be at x equals 2? Yeah, I'm sticking with x equals 1. So let's do this one last time. Y minus y1 equals mx minus x1. All right, y minus y1 equals mx minus x1. So my y1 is 0. Exciting. All right, equals m, which is negative 12, x minus 1. Well, suppose y minus 0 is just y. I didn't really need to do anything. And there's no double negative, so that becomes, distribute the negative, and I get negative 12x. Negative 12 times negative 1 is positive 12. You see how easy that was? Okay. For the last time, let's check the graph, and let's compare the tangent line to that graph. Okay. So recall that the graph that we care about is this ridiculous 3x minus 1 times x squared minus 8x plus 7. It's a dotted line. Oof. Bendy, 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 bendy. Well, luckily, I only care about when x is equal to 1. And look, that slope, it looks pretty steep. Let's see if that tangent line touches it. Bam! All right. Well, I'm sure you've had enough of my excitement over tangent lines. It's a big part of calculus. If you can get this in calculus, you're going to get at least a B. I guarantee it. Just put in the effort, and I know you guys will do great. The test will be due Monday at 11:59 p.m. Good luck.